Welcome to today's lesson. In this first tutorial, we will write the equation for a polynomial given its roots. And we're now in section 5.7, and we're going to be finding all roots or all zeros today for polynomials. But let's first recall a few facts. If some number a is a zero, then x minus a is its factor. And backwards, if x minus a is a factor, then a is the zero. So remember the difference between what a zero is, that's just the number, and what the factor is, that is x minus that number. And thirdly, the degree will tell us how many solutions we have, how many solutions exist. If we have any x-intercepts, those represent all of our real solutions. If we have any more, then those must be imaginary zeros, and we'll be able to find all of them today. Before we start writing our equations, let's look at the irrational and complex conjugate theorem. If we have irrational solutions, or if we have imaginary solutions, they will always occur as pairs called conjugates. We've already looked at this vocabulary word before, conjugates. If irrational answers exist, if we have one of them as a plus the square root of b, that would be one of the forms of an irrational, is a root, then its conjugate, which is a minus the square root of b, is also. They will always occur as pairs called conjugates. Really, we're just changing the middle sign. A plus the square root of b, a minus the square root of b. Same sort of thing for the imaginaries. If we have a plus bi is a root, then its conjugate must also be a root, and the conjugate of a plus bi is a minus bi. I'll put an exclamation point because I'm excited about that. So this is our irrational and imaginary complex conjugate theorem. They will always occur as pairs, which means we will always have an even number of irrational or imaginary roots. It doesn't make sense to talk about a polynomial that has three imaginary solutions because that cannot happen. They will always occur as pairs, so there will always be an even number of them. Sometimes that number is 0. Okay, now that we know that, let's start writing our equations. This is the backwards idea that we started in the last tutorial. It says, first of all, name all factors, then write as a polynomial function. So if we have these as roots, it looks like one of the roots is 5 and one of the roots is 2i, and I want to write the polynomial function, well, the first thing I might be thinking is, wait a minute, we're missing something. If 2i is one of our solutions, that's clearly imaginary because I see the little I. If 2i is a solution, then negative 2i would also have to be a solution because this first one is 0 plus 2i, so its conjugate 0 minus 2i has to be there as well. Remember, imaginaries will always occur as pairs. So now it's clear that we have 3 roots. Let's write them into factors. If 5 is a root, then x minus 5 is its factor. If 2i is a root, then x minus 2i is its factor. And if negative 2i is a root, then x plus 2i is its factor. So we are in our same situation where we have 3 binomials that we need to multiply together. In this case, I definitely want to multiply the binomials that have the conjugates together first. So I'm going to sort of group them together first and multiply. I'm going to distribute here first. I'll leave the x minus 5 alone. I'll bring that down here in a minute. So x times x becomes my x squared. X times positive 2i becomes 2ix. x times negative 2i becomes negative 2ix. And then negative 2i times positive 2i becomes negative 4i squared. Now remember, negative 4i squared is not going to last long in my work. I squared represents negative 1, so negative 4i squared represents positive 4. I will put a slash through that and change it to positive 4. And now when I add all of this together, you see the inner and outer terms cancel away, and I have x squared and then plus 4. Now don't forget that we still have this other factor to multiply the x minus 5. And I will double distribute yet again. X times x squared becomes x cubed. X times 4 is 4x. Negative 5 times x squared is negative 5x squared. And negative 5 times 4 is negative 20. None of these are like terms, but I do want to do one little thing. This isn't written in standard form because my squared term should come second after my cubic term. So when I name it, I'll name it with my fancy symbol. I'll be boring and do f of x, but that's fine. As long as there's a fancy name for our polynomial, we're good. I'll put my x cubed, and then I will put my negative 5x squared, and then I will put my positive 4x, and then, of course, my negative 20. And there I have written the polynomial function that has these three roots. If we look at our second example, we have these roots. We have 3 and we have 1 minus the square root of 5. Well, again, this is an irrational number, so it cannot be all by itself. We need its counterpart. Its conjugate, 1 plus the square root of 5, must also be an answer. Now, when we have binomial roots, it gets a little tricky as to how to write them as factors and put them into a polynomial. I like to do a method called uncompleting the square. We practiced completing the square. I'm going to do uncomplete the square, which is basically taking all of those steps and going backwards. If these are our two answers, completing the square would end with x equals those two answers, 1 plus or minus the square root of 5. I'll just put them both together. What I want to do is uncomplete the square. That's repeat the, or go backwards with this process. The last thing we did before we solved for x was we got rid of this number. So if we bring this number back to it, we'll start the process of uncompleting the square. We'd have x minus 1 equals plus or minus the square root of 5. And then this square root came about because we took the square root. So I want to undo that and square both sides. So now I will have x minus 1 times x minus 1. I'll go ahead and write it side by side so I remember to FOIL. I don't care if I'm squaring a positive or a negative. Squaring a number will make it positive, and the square root and the square cancel away, and we just get the 5. Now I do need to FOIL this out, but I've done this process so many times that hopefully we can see the pattern going from x minus 1 quantity squared to x squared minus 2x plus 1. We took this perfect square trinomial and factored it into a quantity squared, so hopefully we can go backwards and FOIL it to what it is supposed to be. That's still equal to 5. And then ultimately I want to set it equal to 0, or I want to bring this number back into this quadratic part. So I'm going to subtract 5, and now I have x squared minus 2x minus 4. So that's the quadratic that has these two irrational solutions. So that's kind of nice. Now I have that. What I'm going to do with that is I'm going to, don't forget we still have this other root, I'm going to take this x minus 3, that would be the factor for this guy, and these factors we just found by uncompleting the square turn into x squared minus 2x minus 4. And then I can multiply this together and I'll have my final polynomial. So now we just go back into this. Well, this is a triple distribution. So x times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 4 is negative 4x. We'll go underneath. I'll change color. Let's do blue. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2x is positive 6x. And negative 3 times negative 4 is positive 12. Attention to detail. Every single one of these products is important to make sure that you do correctly. And let's name this, we will name this one b of x, all right? Because it's part b. So we've got x cubed, and this makes negative 5x squared. And this makes positive 2x, and then plus 12. I'll box that in, and I'm very proud of that answer because it took a little bit of work to do. Yes, there are other ways to get to this trinomial, but I think that this is a nice, intelligent way, and I think that it's the fastest way. So thanks for watching that one. And we've got one more to do. So here's part C. I've got 2 plus I as one of my answers, and negative square root of 3. All right, well, hold on now. If 2 plus I is one of the answers, you know that 2 minus I has to be right behind it. They have to be as pairs. And this is irrational because I see a square root. So if negative square root of 3 is an answer, you know that positive square root of 3 has to be an answer as well. Okay, so the monomials, those are not going to be too difficult to do, but the binomials, that's where I'm going to do the uncomplete the square. So let's do the uncomplete the square first. I'm going to say that x equals these two numbers, 2 plus or minus I. And now let's uncomplete the square. So we'll subtract the 2, we'll bring that back to the x, and I will have x minus 2 equals plus or minus I. And then I'm going to take this each side and square, because that's what I would have done backwards. So x minus 2 quantity squared becomes x squared minus 4x plus 4. If you need to write them side by side and do your FOIL, that's absolutely fine. If you see the pattern still, or if you see the pattern already, that would be great too. I squared is negative 1. Negative I squared is also negative 1. And then one last step, let's add the 1 back on in, and I will have x squared minus 4x plus 5. So that's the quadratic that has these two solutions. Great. Let's take these irrational answers and let's come and do this over here. The first one, negative square root of 3, would have a factor of x plus the square root of 3. The second one would have a factor of x minus the square root of 3. That's not too bad. I can do a quick FOIL on this one. X times x is x squared. X times negative square root of 3 is negative square root of 3, negative square root of 3 with an x. And don't worry about that because the next one's going to be exact opposite. So they will cancel away. And positive square root of 3 times negative square root of 3 becomes negative square root of 9. Let's add this together. These cancel away. And I have x squared minus, well, the square root of 9 is just 3. Great. So I have this quadratic and I have this quadratic. And now I simply need to multiply them both together. I'm going to put the binomial one, x squared minus 3, first, and then the trinomial one, x squared minus 4x plus 5. And now let's multiply all this stuff together. Nice little triple distribution here. And I get x to the 4th, x squared times x squared is x to the 4th, x squared times negative 4x is negative 4x cubed, and x squared times 5 is 5x squared. Change my colors. Negative 3 times x squared, that goes right here. I like to line up my like terms. Negative 3 times negative 4x is positive 12x, and negative 3 times 5 is negative 15. So I only have one set of like terms there. Call this one marsh of x again. And we got x to the 4th. Negative 4x cubed. This adds up to 2x squared. And then I've got the rest. 12x and minus 15. And that's a nice long problem, and we ended up with a quartic. 4 answers. 2 of them were imaginary. 2 of them were irrational, and they both occurred as conjugates. Thanks for watching this tutorial. We'll practice writing our polynomial equations in class. See ya.